In this video, we look at an example of how you would find the value of a normally distributed variable from a probability. All right, now here is a typical question related to this concept. Suppose the question is, a trigonometry test is given to a class and the test score results are normally distributed with a mean 75 and standard deviation 7. If 92 is used as a cutoff score, what percentage of students would get an A? In the second part, ask us if the instructor gives A's to approximately 10% of students, but not less than 10%, what's the cutoff score for an A? All right, so here we got the question, and there's certain key words in the problem statement that let us know to do certain things. All right, so this one part of this question, it says normally distributed. So from that, we can draw a bell curve and put our values on a bell curve. All right, where on our bell curve, the sample mean is put at the center of the curve. All right, so here's a picture for number one. We got a bell curve right here due to the word normal distribution, and the mean, the sample mean is at the center, right? And I put the standard deviation, which is represented by S over here, and we're given a data value, which is 92. They told us a data value of 92 or a score of 92 was the cutoff score for an A. And the question is, we want to know what percent of this total distribution is this region right here to the right of 92. All right. Now, if you remember that, the total area under this curve is 1 and is used to represent the probability or the percentage of getting any test score. All right. And our goal is to find out what percent of all of those students who took the test had scores greater than 92. Right? And those students would have an A in the course, right? So that's the question. We're just trying to understand what the question is asking. All right, and then in number 2, they say if the instructor gives A's to approximately 10% of students, but not less than 10, what's the cutoff score for an A? So this question in pictures is this. Again, we got a standard deviation 7. We got a mean 75. This time we're given this percentage. We know this percentage, whereas before we did not know this percentage, whereas here we do know the percentage. And in number 2, we're trying to find out what does this cutoff score have to be in order that 10% get an A. All right, so I hope this question is very, very clear. And if not, it's okay. As you do more and more questions, you're going to feel so much better about this. At the very beginning and when you're first learning it, it seems very, very complicated. All right, but let's go ahead and proceed. So now that we know what the question is asking, let us go ahead now and look at the 2 common ways to solve a problem like this. The first way is by using a normal distribution table. All right. Any instructor would probably provide you with these tables. All right. These tables are not something you memorize. You just are given the tables and you can use those to solve these types of problems. Or you can use a graphing calculator. With the graphing calculator, no tables are needed. All right. Let's try to solve this problem using both ways. All right, let's do number 1. For number one, we're going to use tables, let's say. All right, and here's the question again in pictures. All right, so we're given a mean, we're given a sample standard deviation, we're given a data value or one of the test scores, the cutoff score for an A. All right, and we need to know what this area here is. All right, so we need to find this right area, right? And when you're using the tables, it always only gives you the left area. All right, so you have to keep that in mind, that tables only give the left area. And we want to find here this right area. All right, so just for your information, we'll come back to that, but what relationship relates the mean, a data value, and the sample standard deviation? And that is a z-score, right? A z-score is a quantity that you will need to use the tables if you're given a data value. So the z-score is found from this formula here, z equal x minus x bar over s. And when we substitute our values into this formula, we're going to have 92 over 7, which is giving us 17 over 7, which is approximately 2.43. So now, see, now that we know the z-score, right, we can look in the tables and look at the area corresponding to a z-score of 2.43. But again, the tables only give the left area. So let's go ahead and find out what the left area is. So I'm going to just write this z equal 2.43 has a corresponding left area. What? This is where we put in go to our tables. All right, so I'm going to go to the tables here, look up 2.43. So here is our normal distribution tables. The z-score is in the far left, or the first two decimal places of the z-score are on the far left, and the last two decimal places of the z-score are going to the right here. So 2.43, here's 2.0 right here. And then I go to the right until I get up to 2.43. But no, this is 2.0. I got to go to 2.4. And then I go to 3, right? The 300ths column. So right here, here is our value that we need. You know, this is the corresponding left area, 0.99245. 0.99245. So it has a corresponding left area, 0.99245. All right. But again, we did not need the left area. We need the right area. So in order for us to get that right area, we're going to do right area. Right area is equal to 1 minus the left area. because again, this whole region here is 1. The area under this curve is 1, which is also like 100%. So 100% minus 0.99245, or 1 minus 0.99245. That's going to give us, what is that going to give us? It's going to give us it's going to give us approximately 0.0075, approximately, right? And then, but what is this? What is this? In the textbook, they might ask you, what is this value as a percentage, right? So to find this value as a percentage, all you do is multiply it by 100 or move the decimal 2 places to the right. So as a percentage, this becomes 0.75. All right, and then even more, they might say, what is this value after you? What is this value as a percentage after you round to 1 decimal place? So rounding this to 1 decimal place, I looked at the tenths place, and I look to the right of the tenths place, and I see that this is 5 or more. So that means I move this 0.7 up 1. So the answer after rounding to the 1 decimal place is going to become 0.8, right? All right, let's move to number 2. This time we've got a similar question, but a little bit different. We're given, again, the sample standard deviation. We're given the mean. We're given this area this time, or this probability, or this percentage of the total distribution. But this time we want to find out, what is this score there? What is that data value there? And just like before, there's a relationship relating all of those quantities, and that is that z equal x minus x bar over s. And if you do some algebra on this, you'll see that this can be solved for x to give us x equal x bar plus zs, right? And so you can see now that all we need, we already know x bar, we already know s, but we do not know z. If we can find z, then we can find x, right? Because we know x bar is 75. We know s is 7. If we can only find z, then we can know what x is. All right, so in order to find that z, we need to this z corresponds to the left area, 0.9, right? Because again, the table always gives the left area. So we need a z value that corresponds to this left area. But what is that left area? You can see that this 10% here, if this is 10% of the total area of this under this curve, then what must the other part of this, uh, area be here? This part of the curve has got to be 90%. Do you see why it has to be 90% if this part is 10%? Because the total area under the curve is 100% or 1. So this side or this part or this region of the curve has to be 90%. And this represents the left area. So we need the z-score corresponding to this 90% or 0.9, right? So we're going to look in the tables and see if we can find a z-score closest to 0.9, right? Let me go ahead and write this. We need a z-score corresponding to a left area 0.9. All right, so then we're going to go to our tables and see where we can find 0.9. So here we're not looking at the z-score yet, we're looking at the area. So the area is in here, all of this stuff in here. So we're looking for the closest number to 0.9. And let's see if we could see here. Here's 0.90, 0.90147, 0.89973. This number right here is the closest number on this chart to 0.90 or 0.9. So, and now, what is the corresponding z-score? Well, if I look to the left, see 1.2. If I look up above that value, I see 8.08. So 1.28 is the z-score. So I go back 1.28. 1.28. That z-score is 1.28, right? So now that we have that z-score, we can just substitute it into our formula and the answer should pop out, right? So let's go ahead and do that. So we're going to go x equal x bar was 75. I'm substituting into this. So x bar is 75 plus 1.28 times s, which is 7. And when you work this out, you're going to get 83.96. All right, and if they ask you, they're going to ask you to round down, right? That's unusual to ask to round down, but that's what they ask sometimes, is to round down. So this is the answer after rounding down to the nearest whole number. All right, so here's our final answer for x, right? So I hope you've seen how we found it using tables, right? Tables it is a little complicated at the beginning, but as you do many of them, you'll feel good about it. And again, this is the formula that you're using. All right, now let's look at how to solve these same questions using the graphing calculator. All right, so for that first problem, the question was, if you're given a sample standard deviation with the normal distribution, mean 75, 92 is your data value, and you're trying to find, this area here to the right, how do you do it, right? So using the graphing calculator on this, you would use a procedure on the calculator. It's called the what is that called? Normal CDF. All right. So to get to that normal CDF, we just turn on our calculator. There we go. And we're going to go to second bars. All right. And let me show you the procedure right here. Second bars, right? So I'm going to second bars, then I'm going to normal CDF. And the calculator is going to require a lower limit, an upper limit, a mean, and a standard deviation. Now, if I want this area right here, what is the lower limit? It's 92. Hope you can see that. If I want this whole area, the lower limit is 92. The upper limit, there is no upper limit. So I just pick a big number way bigger than 92. So like 9999 or something like that. And then I also got to put in the mean. And our mean is 75 and the standard deviation is 7. All right? And make sure you use commas to separate these quantities. All right, so let's see if our calculator will work again. All right, so here we go, normal CDF. And I think normal CDF means, I looked it up, somewhere, normal CDF, I think it means cumulative or normal cumulative density function or something like that, right? And anyway, let's go ahead and enter. And again, we got to put our lower limit here. So we're going to put 92 and then comma. And next we're going to put any arbitrary big number, comma. And next we're going to put the mean, which is 75, comma. And next we're going to put our standard deviation, 7, close parenthesis, and then enter. And then you can see that our, right area here is 0.0075, right? You can see that. 0.0075, again, this is, if you round this or if you want to change this to a percent, what is it going to be? It's going to be 0.7579. And then if you round this to the nearest one decimal place, you're going to get 0.8, after rounding to one decimal place. All right, so that was very easy, I hope. And then for number 2, similar thing. Right here, we wanted to find x, and this time we do the inverse normal distribution feature on the calculator. So we're going to go, this time, we're going to put in our left area here in the first, as a first quantity, and then the mean and standard deviation, right? So what is the left area? See, we're given the right area, right? So you got to make sure you put the left area here on the calculator. So Uh, what is that right area or left area? It is 0.9. If this is 0.10, this has got to be 0.9. So we're going to put that in. This time we're going to go to second vars, and then you'll see the inverse normal function on the calculator. Let's see if we can find that. So we're going to go to second vars, inverse norm, and then enter. And then we're going to put in the left area, which is 0.9, comma. Then we're going to put in the mean, which is 75, comma. And then we're going to put in 7, and then enter, and our answer will pop out. And you can see it's 83.9, which is what we had before when we did the last one. And then when you round down, you get 83, right? To the nearest whole number down.